Greetings, I'm Rifa Ahmed Maisha. I studied electrical and electronic engineering from Dhaka University. Today I will talk about Clipper circuits. In my discussion, I will cover definition of Clipper circuits and classification of Clipper circuits such as series Clipper circuits and parallel Clipper circuits and its application. So Clipper circuits are wave shaping circuits. They clip off or removes a certain portion of the applied signal while the rest of the signal remains intact. The simplest form of Clipper circuit consists of a diode and a resistive load. In the picture, we can see a Clipper circuit and an output is taken from the diode. So during the positive half cycle, the diode is forward bias and short circuit. So the output voltage is equal to the short circuit voltage and that is 0 volt. And during the negative half cycle, the diode is reverse bias and open circuit. That's why using KVL, we can get output voltage is equal to input voltage. And if we see the waveform, we can see that the positive part of the input signal is clipped off while the negative part of the signal followed the input signal. Depending on the configuration, clippers can be divided into two categories, such as series and parallel clippers. For series clippers, diode is in series with the resistive load and output is taken from the resistance. So in figure 1, if we apply positive half cycle, we can get the diode is forward bias and short circuit. So applying KVL, we can write diode is ideal diode, that's why diode voltage is 0. So output equal to input. During the negative half cycle, the diode is reverse bias and so 0 current flows through the resistance. That's why output is 0. If we draw the waveform, we can see the positive half cycle followed the input signal while the negative half cycle is clipped off. For figure 2, if we apply positive half cycle, the diode is reverse bias. That's why output in an open circuit, that's why output voltage is 0. And during the negative half cycle, the diode is forward bias and output voltage equal to input voltage. Here the positive part is clipped off, that's why it is a positive clipper. For bias series clipper circuits, a bias voltage V is used. So in figure 1, if we apply positive half cycle, when V input is greater than bias voltage, the diode is forward bias and short circuit. So by applying KVL, we can write output equal to input voltage minus bias voltage. During the negative half cycle, the output voltage is when input is less than bias voltage, the output voltage equal to 0. So if we draw the waveform, we can see this form. For figure 2, during the positive half cycle, when input voltage is greater than output voltage, the diode is short circuit, the diode is open circuit and output voltage is equal to 0. And during the negative half cycle, when less than output voltage, applying KVL, we can write we draw the waveform, we can get this. As the positive part is clipped off, it is the biased positive clipper. For parallel clipper, diode is in parallel with the resistive load. So for figure 1, during the positive half cycle, as the output is taken from the diode is reverse bias and output voltage is equal to input voltage. And for negative half cycle, the diode is forward bias and short circuit. That's why output voltage is equal to 0. If we draw the waveform, it will look like this. The positive part followed the input voltage while the negative part of the signal is clipped off. For figure 2, we can see that during the positive half cycle, the diode is forward bias and short circuit. That's why output voltage is 0. And during the negative half cycle, the diode voltage is reverse bias and open circuit. That's why the output voltage is equal to input voltage. So if we write the waveform, it will look like this. Here the positive part is clipped off. That's why it is a positive clipper. For biased parallel clipper circuits, for figure 1, during the positive half cycle, the diode is reverse bias. That's why output voltage equal to input voltage. And during the negative half cycle, the diode is forward bias and it is short circuit. That's why output voltage will be equal to the negative of the bias voltage. So if we draw the waveform, it will look like this. Here the waveform is clipped off after the bias voltage. For figure 2, during the positive half cycle, the diode is forward bias and open short circuit. That's why the output voltage will be equal to the bias voltage. And during the negative half cycle, the diode is reverse bias and open circuit. That's why the output voltage will follow the input voltage. If we write the waveform, it will look like this. Here the positive part of the signal is clipped off after the bias voltage. Here both forward bias diode and reverse bias diode is used. So during the positive half cycle, this portion of the circuit will dominate and the diode will be forward bias and short circuit. So the output voltage will be equal to the bias voltage. And during the negative half cycle, this portion of the circuit will dominate and the diode will be forward bias and short circuit. So the output voltage will be the negative of the bias voltage. So if we draw the waveform, it will look like this. Based on the application of clipper circuits, they can be classified. Based on the application of clipper circuits, they can be used in rectification. The simplest form of clipper circuit is a half-wave rectifier. They are also used to remove noise from a signal, and they generate new waveform by clipping off the positive and negative part. That's all. That's all for clipper circuits. Thank you for your patient hearing.